and welcome to the series of lectures on big data. In today's lecture, we are going to talk about a very important framework of big data called Hadoop. Before understanding the use of this framework, let us understand what are the problems that we are facing in today's era while working with big data. Now, there are three main problems that occurs while working with big data. The first and most important problem is storing a huge voluminous data that is being produced today. The second problem was storing a complex structured data with the help of traditional storage systems. And the third problem with big data is the processing of this voluminous amount of data. Now, with the previous discussion, we have already understood that Hadoop is providing a solution to all these three problems that we are having. The problem of storage and processing is solved with a framework called Hadoop. Now, Hadoop is an open source Java-based programming framework that allows us to store and process large data sets in parallel and distributed fashion. Basically, Hadoop helps us to store the data that is being produced today, a large size of data, in a parallel fashion and in a distributed manner. It means now we are not storing the data at a single machine or a single device. We are distributing this data onto multiple machines. It means a cluster of machines. And along with that, we are processing that distributed data in parallel fashion. So as you can see, Hadoop has two main components that helps us to solve these three problems. The first component of Hadoop is HDFS, which stands for Hadoop Distributed File System. And the second component of Hadoop is MapReduce. Now, this HDFS, Hadoop Distributed File System, is the storage unit of Hadoop, which helps us and allows us to store any type of data, any sized data, any sort of data across the entire cluster of Hadoop. Whereas MapReduce is the processing unit of Hadoop. It allows the parallel processing of the data that has been stored in HDFS. Let us take an example and understand how these two units and components are working. Let us say you have a restaurant, and initially at the starting of your restaurant, you are only having one chef. And because it is a new restaurant, the orders are limited. Let's say in 1 hour, you are getting 2 orders. And the chef can easily manage and prepare these 2 orders in an appropriate amount of time. As soon as the time increases and your restaurant starts to get more customers, the size and the amount and the order has been increased day by day. Now, per hour, you are getting, let's say, 20 orders. And for a single chef, it is not possible to serve this much number of orders for a restricted time of line. So, what is the solution for this problem? The solution can be that you can have more number of chefs and you can distribute the tasks among the chefs. What happens here is, now when in 1 hour you are getting 20 orders and you are having, let's say, 10 chefs, each chef can handle 2 orders for 1 hour very easily, right? So what you are doing, you are getting a task, you are getting some data, you are getting the order, and you are distributing these orders between these chefs. Now, let's say another problems occur that you are having a single unit or store unit where some restricted amount of components can be stored. ingredients can be stored. Now, each and every chef while preparing the meal will be requiring, let's say same thing, let's say they'll be requiring same butter or same milk or same flour. So it will not be possible to store a large number of ingredients in that particular shelf. What is the solution for this? You can increase the number of shelves or the storage units. This is exactly what we are doing with Hadoop. We are increasing the storage, and we are not only increasing the storage, we are parallelly processing these elements one by one. Right? So the distributed storage and the parallel execution removes the problem of storing and processing of big data. Now let us move forward and understand the working of these components one by one. Now, the first component or the storage problem is been solved by HDFS. As I told you, HDFS is Hadoop distributed file system which works as the storage unit of Hadoop. It means you are dumping your data in HDFS now. And this HDFS is nothing but the distributed file system. It means now whenever you are dumping your data into HDFS, it is distributing that data over multiple machines. Now, there are data nodes that are helping us to keeping this data stored, and there are name nodes that are helping to manage the account of these data nodes. So, the HDFS, as you can see on your screens, combines two things. One is the name node, another is the data nodes. Now, this entire architecture is working on the concept of master-slave architecture, where the name nodes are the master nodes, whereas the data nodes are the slave nodes. Now, understand this. HDFS provides abstraction of resources to us. What is the meaning of abstraction of resources? That it provides, just like virtualization, it provides you a view that you are dumping your data or you're storing your data on a single machine or on a single device. But in the backdrop, what HDFS is doing, it is distributing that file into multiple components, into multiple subfiles, and then it is storing these subfiles on these data nodes. So it is providing abstraction of these resources to the user. So it divides the file, whatever you are storing into the system, whatever you are writing into the system, into smaller sized blocks. And then it is storing those blocks across the cluster. Let us take an example. Let us say I have a file that I want to write named A. Now this file, when I am going to write into the HDFS, I am just writing it into a single file naming A. But what HDFS is doing, it is dividing this file into multiple parts. Let's say it is dividing it in A1, A2 and A3 in 3 parts. And then after dividing it into the smaller size chunks, these are the smallest size chunks. Let's say this was of 512 MB. So it might be dividing them into 128 MB of 4 blocks. Right? Now after dividing this file into smaller chunks or smaller data blocks, it is dropping them over the cluster. It means it is storing these chunks into the data nodes. Now let's say this is my data node 1, this is data node 2, this is data node 3. There are 3 data nodes that are available with us. So what your HDFS will be doing, it will be storing A1 here, let's say A2 in this server and A3 in this machine. It will not only be storing these files, it will be replicating these files as well. And then it will be storing these replicas in the data node as well. It means it will be taking out the replica of A1 and that replica might be stored on the second device A1. Another replica of A2 might be stored at first machine. In the same way, another replica of A3 might be stored A3, right? Let's say here it is 2, here it is 3. So it is not only dividing the data files, it is also replicating these data files. Now, why replication is required? Understand this, because we are working in a distributed fashion, in a distributed architecture. So what might be possible that at certain point of time, a node can be corrupted. It will not be working maybe. Once it will stop working, what can happen if this node which was storing, let's say A1 and which is storing, let's say A2 has been disturbed, has been broken down, has been corrupted, then what will be the option of retrieving these files? So, for that case, we are making the replicas and storing these replicas on some other data nodes, right? What will happen here when I am storing these replicas onto other data nodes is that whenever this node will not be working, this will be blocked or corrupted or not working form, then I can get this chunk of data A1 from some other data node where we have replicated it, right? So this is how the HDFS not only divides the data files, it also replicates the data files and store them in data nodes. Now in this master-slave architecture, the actual data is being stored at data nodes. So the actual data is being dumped in these data nodes in replicated manner. Whereas the name node is only having metadata. We'll discuss these details when we'll discuss every point of view in the name node. Now, next important aspect of HDFS is that it by default follows horizontal scaling, but we can also do vertical scaling as required. Now, what is horizontal scaling? Understand this. These data nodes, they are not the costlier machines. They are just the commodity hardwares. They are not costlier servers. So, instead, when the size of the data is being growing, instead of increasing the servers, what we can do? We can increase these commodity hardwares, right? The commodity hardwares are at the cheaper front and we can manage them by increasing parallelly. So, whenever my startup or whenever my restaurant is growing and I'm getting higher orders, what I can do? I can always recruit more number of chefs. In the same way, whenever the data is growing, and because the data is growing exponentially, if at the beginning I'm only having 3 data nodes, and if I feel the requirement of adding more data nodes, instead of adding entire master-slave architecture or the server, what we can do? We can add more data nodes now. We can add multiple data nodes because they are cheaper also and they are self-sufficient to manage also. They can be easily managed, right? So, instead of adding higher cost servers, we can use these commodity hardwares and add them to increase the storage. Next, we can store any kind of data. The problem was this only, that we have to store a larger size data. But again, the data that was being produced was of multiple type. It means it was having complex structure. It was unstructured data. So, we can easily dump unstructured data in HDFS. Why? Because it doesn't have any pre-data dumping schema validation scheme. It means we do not have to provide or define a schema, or we do not have to need a schema before dumping the data or before writing on the HDFS. It doesn't require that, which solves the problem of storing the complex data, right? So, these are the points that makes HDFS very much different and feasible from the traditional storage system. Now, let us discuss these master-slave architectures, the master node and the slave node in detail. Now, you can see here, the HDFS was having a master node called name node. Now, this name node is the master daemon which stores the metadata. It stores the metadata. What is the meaning of metadata here is data about the data. But the actual data is being stored at data nodes. So what are we maintaining here? We are maintaining the information of whatever we are dumping in data nodes. It means whatever we are storing in data nodes, its information and its summary will be kept in the name node, right? So name node maintains and manages the data nodes. It handles the working of these data nodes. It controls these data nodes. It records the metadata as I told you. For example, what will be the metadata in this? It might be that how many number of blocks are stored in data node 3, let's say. This is 3, this is 2 and this is 1. So how many number of data blocks are stored in data nodes? What is the size of each data block that has been stored? When was the data block updated last time? When was the data node dumped in this data block was dumped in this data node? What is the location of that particular data block? Whether it is in data node 3, data node 2, data node 1, right? What is the size of that file? What are the permissions? Whether if you want to access a file, whether you are having that permission of that particular data block or not, right? Such things are maintained in the name node. So whenever you have to access, you have to read a data block, and that data block might be present, let's say A1 is present here also and here also, right? So whenever you have to read A1, the input or the command will be circulated first to name node. So the name node will be the first entity to get this input, to get this command. And on the basis of the permissions, on the basis of the file location, on the basis of the hierarchy of allowing to access the file, name node will allow to fetch this data from this node or from this node and then give it back to you, right? That is why it is known as the master daemon of HDFS structure. Now, because it need to manage these data nodes, how it is going to know whether how many number of data nodes are there, which one is in working state, which one is blocked, which is not in working state, right? So for this, what your name node is doing, it is receiving some electrical signals from each and every data node associated with it. Let's say if I am increasing the number of data nodes, if I am adding a new data node, let's say 4. So how it is going to know that this data node 4 which has been added currently is in working state, it is currently working or not. So what it is doing, all these data nodes will be sending electrical signals to the name node, right? And these electrical signals are known as heartbeat. So every data node is sending a heartbeat to the name node in order to make sure that they are working, that they are in correct form, or that either one of them has been blocked or not working properly or not, right? So it receives the heartbeat from each and every data node connected with it, associated with it, right? So this is the working of name node, and this is the use of name node in this structure. Second component was data nodes, where the actual data is being stored. So this is where our actual files are being stored, and these are nothing but the commodity hardwares. These are not costlier devices. We can always, if one of the data node is not working or blocked, we can easily replace it with some other node, right? Now, these are the slave daemons. It means they depend on the instruction that they get from name node. And in order to get these instructions, they have to inform the name node whether they are in working mode or not, right? So they provide heartbeat to name nodes, as we have already discussed, right? So all the read and write requests that a user, that a client is producing, all these requests will be served by data nodes only. Name node is just an intermediary who is telling the client or the file system that which data block is present in which data node. And once it has been identified with name node, the client file system is directly dealing with data nodes. because they are working on these files which has been dumped here, which has been stored here. So whenever I have to access A1, first the command will go to name node. Name node will identify where is the replica stored or where the original file stored, where is that chunk stored. And then once it has been identified that the user who is requesting to read or write has the correct permission. Once all these formalities have been completed, actually the file system is now communicating with this data node directly. So all the read and write requests are served by data nodes only, right? Now let us understand how the data that we are dumping in our HDFS is divided, or on the basis of what we are dividing this data, right? So let us say that we have an XML file and the size of this XML file is 512 MB, right? Every HDFS is having a fixed or by default format of block size. So whenever you dump a file, it automatically divides that file into the fixed block size. And by default, the block size is 128 MB, which can be customized and changed while we are working with HDFS, right? You can increase or decrease it. By default, you get 128 MB. So if you are dumping a file of 128 MB directly, there will be no distribution, no division, no block size division for this particular file. But if you are adding or writing a file higher than this size, 128 in this case, you will be having chunks of these files. Now, when we are dumping 512 MB file, what your HD will be doing? It will be dividing into 4 blocks, each block of 128 MB. Each block of 128 MB, right? After dividing it in the default block size, what will be doing? It will be replicating this block. Be replicating all these blocks. By default, the number of replication is 3, which is also customizable. So when we are following the by default size, it will be replicated in 3 copies. Again, the second block will be replicated in 3 copies. This will also be replicated in 3 copies, and so same so. After replication, we will be storing it into the data nodes. After this, we will be storing them into the data nodes, right? So this is how the block size is being generated and divided on the basis of the default size that we are having, which can be customized. And in the basis of same way, we can replicate the files and then we dump them into the data nodes. So up till now, we have completed the discussion on the architecture of Hadoop, 2 important components of Hadoop and how HDFS works. In next lecture, we are going to continue this discussion with further more details. Thank you very much.